Module 3, Lesson 2, Real World Positive and Negative Numbers and Zero. So continuing our exploration of the number line and expanding our thinking to include negative numbers. All right, I can statements. I can use positive and negative numbers to indicate a change, a gain or a loss, and temperature and the balance in a bank account. I can use vocabulary precisely to describe and represent situations involving integers. I can choose and apply an appropriate scale for a number line when given a set of positive and negative numbers to graph. So kind of a grab bag of different concepts today. All right, opening exercise here. How would you show 150 on a number line? And of course, you should pause at this point, think your way through it, maybe actually explain to someone. And a quick answer would be I'd start at 0 and I would move to the right 150 units. So on the number line we have here, what strategy would you use to show 150 on the number line? And you might want to pause there and think about a few different ways that you could show 150 on the number line. Now, a couple strategies that you could do would be to put a 0 as far to the left as possible. And then we could use tens. So 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120, 130, 140, 150. And of course, you could take the time to write all of those out, but I am trying to not take too long in these videos. Sometimes I am more successful, and other times I am less. So one possibility would be to go from 0 to 150. I could also start at 140 and count by ones. 141, 142, 43, 44, 45, 46, 47, 48, 49, and get to 150. I could similarly start at 140 and count by twos to 142, 144, 146, 148, 150. So there are a lot of different ways that I could represent 150 on the number line. So if you want to have 0 and 150 on the number line, what scales would work well? And remember, when we talk about scale, what would you count by? So I need to have the 0 on the number line, and I need to have 150 on here. What could I count by that would work well? And this would be a great time to pause, think about that, maybe discuss it with a neighbor. Well, I could count by fives. 5, 10, 15, 20, and I could continue up to 150 somewhere out here. I'm not sure which line it would be on. I could count by tens, which we already looked at. I could count by 25s. 25, 50, 75, 100, 125, 150. I could count by 50s. Not very useful, but I could count by 150s. You'll notice the larger the scale, the larger the count bys, the less detail we have on the number line. If I count by 150s, in this space in between here, I can't really see 25s or 50s or 10s or 5s. So we have to be thoughtful as we choose the scale, that we don't wind up picking a scale that does not provide a good representation of what we're working with. All right, so here we go, example 1, and we're working on the I can statement for vocabulary here, that we can use precise vocabulary, so we need to build some vocabulary. So you would read the example, and you would write down any words and definitions that you already know. And in the second column, you would write down words that you don't know. And in the third column, you could record words that you had learned. For Tim's 13th birthday, he received $150 in cash from his mom. His dad took him to the bank to open a savings account. Tim gave the cash to the banker to deposit into the account. The banker credited Tim's new account $150 and gave Tim a receipt. 1 week later, Tim deposited another $25 that he had earned as an allowance. The next month, Tim's dad gave him permission to withdraw $35 to buy a new video game. Tim's dad explained that the bank would charge a $5 fee for each withdrawal from the savings account, and that each withdrawal and charge results in a debit to the account. So make sure you pause here, look through, find the words that you're not sure what they mean, record the words that you already know, and let's take a look at some different words. So some words that you might already be familiar with: a bank account, a place where you put your money, receipts, tickets that they give you to show how much that you spent, an allowance, money that you received for chores or simply because your parents just want to give you money. Doesn't seem to happen very often. Charge, something that you pay. And some words that you might want to know, or words that you might not be familiar with: credited, debit, fee, deposit, and withdraw. Now, obviously, each individual person who reads this might have different lists of words, and I'm trying to work with just some general ones. So we're going to take a look on this next slide here, and we're going to figure out kind of what these words mean. So we're going to look at the example again, and we're going to number the events in the story problem, and we're going to write the number above each sentence to show the order of the events. And then we're going to think about, what does each of these mean? Oh, I am so silly. Sorry about that. So credited is a positive. It's a number that is in your favor. You receive credit for something. A debit is a minus. It's when they take something away. Fees are money that they charge you for doing things. So in this particular story, we have a $5 fee. They're going to charge you $5. They're going to take $5 from you when you take money out of your account. A deposit is a plus. A deposit for most people is when you're putting money into your account. A withdraw for your bank account would be taking money out. That would be a subtraction. Now, if you want to get really deep on this stuff, and this kind of gets into the field of accounting, which I don't know a whole ton about, but each of these things can also be the opposite depending on your situation. For example, you might be credited money, but the person who gave you the money is experiencing a negative. You may be taking money out of your account, but whoever is receiving the money is getting a positive. So there are two sides to each of these stories. For example, when you withdraw, that's a negative for your bank account, but that's a positive for the money in your pocket. When you deposit money, that's a positive for your bank account, but that is a negative for the money that you have in your pocket. So it's really important to think about what is actually being described in each of these situations. Okay, moving on to the next activity here. So we're going to go through here and we're going to just figure out the order of events. This happened first, this happened second, this was third, this was fourth. For Tim's birthday, he received $150 in cash from his mom. Well, that sounds like the first thing that happened in the story. His dad took him to the bank to open a savings account. Okay, so that sounds like the second thing here. We're opening this savings account. Tim gave the cash to the banker to deposit into the account. So he's giving the cash, and then the banker is going to deposit. The banker credited Tim's new account $150. Okay, so this credit and the deposit are the same thing. Credited Tim's new account $150 and gave Tim a receipt. 1 week later, Tim deposited another $25 that he had earned as an allowance. The next month, Tim's dad gave him permission to withdraw $35. The dad explained that the bank would charge a $5 fee for each withdrawal from the savings account, and that each withdrawal and charge results in a debit. So he gets the permission, is kind of the sixth thing that happens in here, but then he also gets this education on this $5 fee that is going to be withdrawn. So I'm seeing kind of 7 main events in here. Some of them are kind of duplicates of each other. You'll notice that he was giving the cash to the banker, and then right here I see the banker credited. Well, these two things basically go together, so I combined them to make one event. So what we're going to do with that information now is we're going to actually take a look here at each of these situations, and we're going to represent them with an integer. And we're going to consider, is each of these things a positive or negative? And we're going to create just a number line to show this integer. So for example, opening a bank account with $0, is what integer goes with that? Well, it's $0. So we have the integer of 0, and our number line model would show 0. And there are, of course, a wide variety of ways that you could represent 0 on a number line. Now, making a deposit of $150. And as we go through this story, we need to think about this in the perspective of what's happening in the bank account. We're not trying to think about what is going on with our pocket and the amount of money that we have in our pockets. So we're really looking here and saying what's happening to the bank account. So when I make a $150 deposit with a bank account, that is a plus 150 for the bank account. Yay, bank account. And if I were to show this as an integer, I would show this as a positive 150. Now, these two events here, the making the deposit and crediting, those are both the connected event. They're the same thing happening within the story, but we need to recognize that a credit is 150. So our bank account is going to have this balance of $150. And then a week later he comes back and he makes a deposit of $25, and that's a positive 25. That's a plus for what's in his bank account. Now, he's going to withdraw this $35, following the flow of the story here. He's going to take $35 out. So from the perspective of the bank account, that's a negative 35. That's a minus in the bank account. At the same time, the bank is going to charge him $5. And I might even want to go back and remake this, because I wish the $35 withdrawal was first and then the bank charge. But so we've got a bank charge of negative $5, and we have Tim's withdrawal of negative $35. All right, taking a look at another example. Moving from money now to temperature, the other part of our I CAN statement. Temperature is commonly measured using one of two scales, Celsius or Fahrenheit. In the United States, the Fahrenheit system continues to be the accepted standard for non-scientific use. So for everyday use in the United States, we're using Fahrenheit. For science, we will normally use Celsius. All other countries have adopted Celsius as the primary scale in use. The thermometer shows how both scales are related. So we have this image of a thermometer, and we can take a moment here and we can analyze the number lines that we have. First, we have a vertical number line, and on the left-hand side here we have Fahrenheit, and on the right-hand side here we have Celsius. Now, as I look at these number lines, I will notice that they're both counting by basically the same things here. But the big difference is how far apart are the numbers that they're counting. So here we're counting 10, 12, 14, 16, 18, and 20. And over here we're counting 10, 12. Ooh, that's very precise for my marker here, and it's not going to be that precise. So 10, 12, 14, 16, 18, and 20. So the lines are closer together on the Fahrenheit side than on the Celsius side. So even though they're counting by the same thing, how far apart they put the numbers is different, which is why temperatures in Celsius and Fahrenheit are not the same. All right, so looking at some examples here, some thinking. The boiling point of water is 100 degrees Celsius. Where is 100 degrees Celsius located on the thermometer to the right? So pause for a moment, take a look, and find 100 degrees Celsius on the thermometer. Now hopefully you're looking and saying 100 degrees Celsius isn't there. The temperature scale is stopping at 50 degrees Celsius. Excellent observation. 100 degrees Celsius would be twice as far up. We'd need to double the length of our number line. So describe the position of the integer that represents 100 degrees Celsius as it would appear on a double number line. Well, it would be twice as far up. So it would be 100 units above the 0. So here's the 0, here's 50, and we would have to keep going up so that we could reach 100 units. So the integer 100 degrees for 100 degrees Celsius would be 100 units above the 0 of the Celsius. All right, taking a look here at some examples. So write each temperature as an integer. The temperature shown on the thermometer in degrees Fahrenheit. So they're asking for a Fahrenheit reading, so I need to look at the Fahrenheit scale, and they would like me to interpret what does it say about Fahrenheit. Well, the red line here is at 100 degrees Fahrenheit. The temperature shown on the thermometer in degrees Celsius. So now I'm shifting from the Fahrenheit scale to the Celsius scale, and I can see that I've got 30 right here, 32, 34, 36, 38, 40. I'm counting by twos. So we're at 38 degrees Celsius. And the freezing point of water in degrees Celsius. Well, it's pointing right at 0 degrees. So the freezing point of water in degrees Celsius is 0. All right, so if someone tells you your body temperature is 98.6 degrees, what scale is being used? So you go to the doctor and they take your temperature and they say, sorry, your temperature is normal, 98.6. What scale are they using? Is that in Fahrenheit or is that in Celsius? And how do you know? So pause and think about that for a moment. And please don't say, well, because they told me it's this. What is some logical reasoning that you can use to explain? Well, water boils at 100 degrees Celsius. And I'm pretty sure that my temperature is not almost boiling. So I really doubt that they are using Celsius for my temperature. I'm really thinking they're using Fahrenheit. Does the temperature 0 degrees mean the same thing on both scales? Is 0 degrees Fahrenheit having the same meaning as 0 degrees Celsius? And pause and think about that for a moment. How would you explain? No. 0 degrees Celsius corresponds to 32 degrees Fahrenheit. If we take a careful look at our thermometer here, the zeros on the scales don't line up to each other. 0 degrees Fahrenheit is down here almost at 18 degrees below 0, negative 18 degrees Celsius. Now, something that we'll frequently hear students say that we should correct right now, we wouldn't say negative 18 degrees Celsius below 0. When we said the negative, we already said below 0. So you can say 18 degrees below 0, or you can say negative 18 degrees, but we aren't going to combine them to be negative 18 degrees below 0. We would call this a double negative. And as we explore opposites of opposites in the future, in future lessons, I almost start to wonder if what this statement would mean would be 18 degrees instead of 18 degrees below 0. So watch out for the dreaded double negative there. Use one, use the other, use the negative, use the below 0, but don't use them both at the same time. All right, so another quick vocab thought process here. Where would you put each of these numbers? Pause and put them in place. Would they be a positive number or a negative number in common usage? And the positive numbers would be gains, deposits, credits, receive. The negative numbers in common usage would be loss, debit, charge, below 0, withdraw, and owe. So here we've got just a set of situations here. We need to write an integer to represent each of the situations. Company loses $345,000 in 2011. That's a negative $345,000. And I will label it with dollars because it's money. You earned $25 for dog sitting. Well, that's $25. If we get really picky, that's a positive. Jacob owes his dad $5. Well, for Jacob, that's a negative 5. For the dad, that's a positive 5. So once again, this, depending upon the perspective, if you're seeing this from Jacob's point of view, this is a negative number. If you're seeing it from his dad's point of view, this is a positive number. The temperature at the sun's surface is about 5,500 degrees Celsius. That's a positive number. We are definitely above 0 there. The temperature outside is 4 degrees below 0. That would be a negative 4. A football player lost 10 yards when he was tackled. Ooh, a loss of 10. From the perspective of the offense, it's a negative 10. The defense is saying, hey, that's 10 in our favor. So once again, depending upon the point of view that you take, each of these situations could potentially be viewed as the opposites. All right, describe a situation that can be modeled by the integer negative 15 and explain what 0 represents in the situation. Great opportunity to pause, do a little bit of writing and thinking about this. A simple situation here, I owe my best friend $15, and that would be negative 15 for me. Boo. And in this situation, 0 represents my owing nothing to my best friend, which would be nice. I would like to not have to owe that money. All right, so how did we represent debit and credit on a number line? Were debits to the left of 0 or to the right of 0? To the left of 0 being negatives, to the right of 0 being positives. Well, debits are negative numbers, and they are located to the left or below 0. And a credit is a positive number, and it's located to the right or above the 0. Can a temperature of negative 9 degrees be described as negative 9 degrees below 0? Why or why not? And I already gave a little speech about this. Here we have the double usage again. We've got the negative and we have the below 0. Use one, use the other, but don't use them both at the same time. Below 0 already means the temperature is negative. Negative already means it's below 0. Don't say it twice. All right, quick look at I can statements here. I can use positive and negative numbers to indicate a change, a gain or a loss in temperature, and the balance in a bank account. I can use vocabulary precisely to describe and represent situations involving integers. I can choose and apply an appropriate scale for a number line when given a set of positive and negative numbers to graph. And we have looked at and worked on all of these in this particular lesson. So this concludes Module 3, Lesson 2. If you've got questions, make sure you talk to your teacher and make sure you complete your problem set.